When in doubt, write it out. When in doubt, write it out. If you look at the problem, you think to yourself, I have no idea what the rule is. You can expand it, you can write it out, simplify, and get the right answer. So today, instead of multiplying powers, where when there were powers being multiplied, today we're going to have powers and we're going to be dividing. So if I have x to the 6th, y to the 4th, z to the 3rd, those are all powers, right? And I'm dividing by x squared, y, and z to the 3rd. You look at that and you're like, I have no idea, Mrs. Long. What are you talking about? That looks crazy. That's hard. It's too much. What?
Wait, you just split the numbers in half. Because the 6. Wait, never mind. Wait, yeah.
When in doubt, if we don't know how to do it, what do you do?
I guess write it out.
Write it out. So, instead of x to the 6th, 1, 2, 3, 4, 5, 6. And instead of y to the 4th, 1, 2, 3, 4. And instead of z to the 3rd, 1, 2, 3, right? Over, instead of x squared, x. And I'm grouping them kind of together. So I'm putting the x's all together. Then I leave a little space, and then I put the y's, which is just one y. And then I put my z's.
Do you just do normal dividing? But the rest change.
Just the way the problem was.
And you just do normal dividing?
So normal dividing. So let's talk about it. Like, what if they were numbers? What if it was 3 divided by 3? What happens to them? Yeah, they become a 1. It cancels out, right? So x divided by x cancels out. What else? Anything else cancel out? Another x and x. What else, Carver? Y divided by y. Okay? And z divided by z, that's a pair. Z divided by z, that cancels out. Z divided by z, that cancels out. So what's the answer? What are we left with?
X to the 4th power, y to the 3rd power.
X to the 4th, y to the 3rd. And that's the answer. We're done.
How'd you get this? Like, if you weren't writing it out,
It's just 4x and 3y.
Wait, couldn't you? Don't you
Can
just?
we just subtract
Wouldn't that
them?
just be
Yeah, because 6
Yeah.
minus 2 equals 4, and then 4 minus 1 equals 3.
So,
3 minus 3 equals
when in doubt, write it out. If you look at this and you're like, I have no idea what to do, expand it all, cancel stuff out, and you get the right answer. It's more work, but it works. Or you can remember the rule. If powers have the same base, again, right? The x's and the x's, the y's and the y's, same base. If it's x to the 6th over y to the 6th, can't do anything. They have to have the same base, the same big number. If they have the same base, and it's a division problem, subtract the exponents.
How would you know what is subtracted by?
Always numerator minus denominator.
I know that, but why isn't it called subtraction?
Because it's not subtracting, it's dividing.
all you do is subtract.
How would we know what to write as a denominator?
I'll show you.
I know that, but like,
I'll show you. We'll get there. You're a step ahead of us. And here's what you do, right? Look. 6 minus 2 was 4. Right? And 4 minus 1 was 3. And 3 minus 3 is... So do I have to put it if it's 0? No. If it's a 1, do I have to put it?
Yeah.
Yes. But if it's a 0, it's gone. All right, so let's try a little bit more, okay? What if you had 6a to the 4th divided by 4a squared? And again, you guys, I get it. You now know the rule. We're still going to write it out for this one example, okay? So that's really 6a over 4a. Right? Right? And I do my canceling. So A's cancel, A's cancel. So what am I left with?
6A.
A to the second power.
You're left with a to the second power. Now let's talk about our coefficients, because these are new.
What's that to divide them?
Yeah. If it was a multiplication problem, what do we do to our coefficients? Multiply them. This is a division problem, so what are we going to do with our exponents? Divide them. So you have two choices. And it kind of depends on the way you think at this moment. Sit up, please. All the way up. Write all this down. You're behind. 6 divided by 4 is 1.5. Decimals are okay, but they're not the best. If it's given to you in fraction form, you should keep it in fraction form. So instead of doing 6 divided by 4, I'm going to simplify. 6 over 4 simplifies to what? 3 over 2. Because it's given to me in fraction form, right? It's written as a fraction. I mean, I get it. It's division. It's 6 divided by 4, right? But it's written in fraction form. So I should probably write it in fraction form. And 6 over 4 simplifies to 3 over 2. Yeah, could you simplify it to 1.5? But unfortunately, as we're starting to learn algebra, this is going to be more acceptable than 1.5, than a mixed number. Okay? Refugio.
So can we use the decimal form?
I'd prefer if you didn't. I get that the decimal form is the same thing. I really do. But it's going to make more sense the more we practice it. Okay? So, if powers have coefficients, what do?
Divide.
You divide them. Or what else can we do if it's written in fraction form?
Put it.
Or simplify them, right?
So either one can be for
No. If it's written like a fraction, your answer should be a fraction. If it's written with a divide sign, right, the bar with the 2 dots, then that's different. But if it's given to you as a fraction, and most of the time it's going to be given to you as a fraction, you need to simplify. Now, am I saying, what if it said 3 over 2? Can you do 3 divided by 2? Or 6 divided by 2? If this said 6 over 2, can you do 6 divided by 2?
Yes.
What is 6 divided by 2? So you divide it. And you're good to go. The answer is 3. But since it's a fraction, since it's 6 over 4, that doesn't work out evenly. Your answer is going to be a fraction value. So now let's talk about this. What if I had 16 x to the third y to the fourth over 2 x y to the seventh? Now again, because this is kind of new, and these are our notes, when in doubt, write it out. So 16 x x x y y y y over 2 x y y y y y y y. Is that correct? Did I do it right? Yeah. So when in doubt, write it out. And especially since this is a new type of problem, when in doubt, write it out especially so that we can see it as it happens. Now let's cancel. So let's see. X's cancel out, right? What else cancels out?
4 Y's.
Some Y's cancel out. 1, 2, 3, 4. I'm going to put my answer over here because I shifted a little bit. Okay, so what does that mean? It means 16 divided by 2 is 8. So right there, do I have a fraction? No, it works. So I can just write 8, correct? All right, what else is left over?
X to the second power.
X to the second power.
Then y to the third power.
But where are those y's?
They're to the right. Like,
They're on the bottom, right?
Yeah.
So I'm going to have to put them on the bottom because they're in the bottom of the fraction, correct? Now here's the question or figure I think you were asking. You were saying something about when do you put them in the bottom. So let's do the math. Let's use our rules. If powers have the same base, subtract the exponents, right? Okay, so let's look. Right here, the same base. What are you going to do? What minus what? 3 minus 1. And what do you get? 2. Which is right there, right? And then you go over here and you subtract 4 minus 7. What do you get? No, you don't. You get negative 3.
Then how come that 3 is a negative?
So, if a power is negative, what? What do you think? If I did that math problem, if I did this problem right here, 16 divided by 2 is 8. So I get 8, right? Because my coefficients I actually divide. And I subtract my exponents. 3 minus 1 is 2. And that's there. And 4 minus 7 is negative 3. If a power is negative, Eduardo, what? It goes in the denominator as a positive. So when you subtract and you get negative 3, that goes automatically to the denominator and becomes a positive. Negative exponents live in the denominator. That's where they are. Because look, if I have 4 up top and 7 down below and I cancel out, I'm left with 3 on the bottom. 4 minus 7 tells me I have 3 left over in the bottom.
So that answers my question.
So that's your question. Yep. John, sit up, please. You have some information that needs to go in your notebook. I want you all the way up, back straight, please. All the way up. Okay. Coefficients get divided, and if they don't divide evenly, they just get simplified, correct? So 3 over 9, can you divide that? It doesn't work out. It gives you a decimal, right? So we don't want a decimal. So we're going to simplify it. 3 over 9 simplifies to what?
1 over 3.
1 over 3. Haley. Okay. Then we start subtracting. 3 minus 4 is -1. So x to the negative first. Where does that live? And it becomes positive. Then I move on to y to the 10th divided by y to the 7th. So I subtract. 10 minus 7 is 3. So it goes on top. That's my answer. I mean, yes, you'll probably, if you got in a book, ones don't really have to be listed unless it's like the number 11, right? So that one coefficient of 1 might disappear to be y to the 3rd over, and in the denominator, the exponent 1 would disappear, so it would just be 3x. But are they both the same? Yeah. They just have coefficients and exponents of 1 listed. So let's try the next one. That's to go to lunch.